Well, here's our third and final example for the day, and what we need to do is talk about what is a fair game. When we talk about all of these games that we play and we're charging money, and what is fair? So we're going to start this problem doing it the same way that we've done every other expected value problem. And the problem is that I have a bag, and it contains 4 red marbles and 7 blue marbles, and we're going to analyze this question. We're going to take 2 marbles out of the bag, pull one out. We're not going to put it back. And then we're going to pull another one out. If the colors match, the player wins $10. If the player draws a red one and then a blue one in that order, the player will win $3. So the best way to start these is with a tree diagram. That will make this problem a little bit more easy to analyze. So the first thing that happens is the player is going to draw a marble out of the bag. And they pull that marble out, and there's really only 2 things that can happen. Okay, there's either going to be a red marble that is drawn, or there's going to be a blue marble. So I'm going to put red and blue. There's either a red marble or a blue marble. The probability that that first marble is red, there are 4 reds out of 11. So the probability that that first marble is red is 4 marbles out of 11. The probability that it's blue, 7 marbles out of 11. Okay, so there's the first draw, 4 reds, 7 blues, and they're going to have to draw again. Once they draw a red marble, and they're going to hold on to it and not put it back, we need to remember that. Okay, they're going to draw a second marble, and it's possible that their second marble is red, and it's possible that their second marble is blue. So let's talk about this. How many red marbles are left in the bag if they already drew one? There are going to be only 3 red marbles left. And there are not 11 marbles in the bag anymore. They are holding on to 1, so there are only 10 marbles left in the bag. Likewise, let's see, blue. There are still 7 blues in the bag because it has not been drawn yet. So there's still 7 blues left out of 10 marbles left in the bag. Okay, now, the probability of getting red and then red. Red, red. If you multiply those 2 numbers together, the probability of getting red, red is 0.1091. Okay, the probability of getting red blue is 4/11 times 7/10, and that probability is 0.2545. All right, now let's go down here. What if blue is drawn first? If blue is drawn first, we still can get red or blue on the second draw, red or blue. And the probabilities here, fix that a little bit, probably getting red. There's still 4 red marbles in the bag because one has not been drawn yet. There's still 4 red marbles. And there are 10 left in the bag because the player is still holding on to the blue. And we multiply 7/11 times 4/10, and that answer actually happens to be the same as the previous one, 0.2545. And let's look at 2 blues in a row. 2 blues. Let's see, 1 blue is drawn, so there are only 6 left. There's 1 ball is missing, so there are 10 marbles left. And we multiply these together, and we get 0.3818. 0.3818. All right, now those are my probabilities, the things that that I'm going to really kind of concentrate on for this problem. And remember, for expected value, what we're looking for is we really kind of need to figure out what all the outcomes are. Okay, what all the outcomes are. And the outcomes are either, let's see, outcomes are right here. Player's going to win $10. Player's going to win $3. Or it's possible that the player loses. Okay, they're going to lose or get $0 if they lose. So nothing happens here. So we need to find these scenarios. $10 if the colors match. Colors will match if we go red, red. This is a matching color, red, red, and that will be a $10 outcome. Okay. Another matching is a blue, blue. Blue, blue is going to be another $10 outcome. So we need to look at what is going to happen if, how we're going to get the $3. Let's take a look at the $3 here. $3 is if red, then blue. So I need to find that here. Red, then blue is this road. Red, then blue. And that outcome there is going to be $3. All right, there's only one outcome left. And that outcome basically is what is the probability that we just flat out lose this game. No win, just go away, nothing happens. So that is going to be the only thing that's left here. 7/11ths, 4/10ths, we've multiplied it. There it is. This outcome is we completely lose and basically nothing good happens there. We walk away from the game with nothing occurring at the end. So we should come up with our probability model. And if you look at my tree diagram right now, there's 4 kind of ends on the tree, but there are really only 3 different outcomes. So I'm going to have over here outcomes, and I'm going to have probability of those outcomes. And the outcomes are $0, I just like to go in order, $3, and $10. The probability that nothing happens, that I lose, and nothing occurs is 0.2545. So 0.2545. And the probability that I win 3 is also 0.2545. 2545. And the probability that we win 10, actually, it looks like it's going to be this one and this one put together. So we need to remember that we're going to have to take these probabilities, this one here, and this one, we need to put them together. We need to add them together, because they both win $10. So when we add those 2 together, we get 0.4909. Okay, this is my probability model. This lists all the outcomes and all the probabilities. And if you remember, once we have that probability model, we then can go down and we can calculate our expected value. All right, we're going to be looking at expected value. And that just says we need to take the outcome, $0, and multiply by its probability, 2545. Add the next one. The next outcome is $3 times 0.2545 plus the next outcome, which is $10, times its probability, which is 0.4909. And we need to calculate all of that out. The first number is 0. You should grab a calculator, and I'll go a little bit slower here, because it's good for you to have a chance to multiply things through and do some things on your own. So try to do this while I talk through it, and while I work it out on my own too. The second number, let's see, we've got a plus here. That second number should be 0.7635 plus. Multiply the next one. Now when you multiply by 10, you can just move the decimal. I'm going to it's not really cheating, it's just using good math here. I will have 4.909. So we'll add those numbers together and take that 0.7635, and we'll add the 4.909, and get an answer, a total of 5. Let's see, write this down here for you. 5.6725. Okay, that is my expected value. Now we're talking money in this case. So if I'm talking money, this is like $5.67 plus, a fraction of a penny. But we're looking at 567 in general for money-wise. And what that means is, to be a fair game means it's even for me, even for you, both player and the person running the game. It's fair because we should break even. A fair game, in this case, says, hey, you know what, this is what I should charge. I should charge 567, 568. It's as fair as we can be. This game's fair because it says on average, the player that's playing the game is going to win 567 and a little penny. And the player running the game, okay, so if the player running the game charges this money, this expected value, in the long run, both players should basically break even, and that would be considered a fair